Welcome to lesson number 3, factoring and applications, and then factoring the trinomials of the form a f of x squared plus b f of x plus c. Okay, so in the last lesson we looked at trinomials of the form x squared plus bx plus c, and trinomials of the form ax squared plus bx plus c. In the first example, we just factored by inspection. So basically, you just looked at it, and you could pull out the factors of that trinomial. With the second one, with decomposition, since there was a variable of a and a variable of b, we had to decompose this trinomial and break it down in order to group the like terms. So in this process, or in this lesson, we're going to extend the process to express the variable x as a function of x. Okay, so that's where this f of x squared plus b, that being the coefficient f of x plus c, comes in, where f of x is itself a monomial, or just one number. So after we take a look at these trinomials, we're going to look at how we can use the method of inspection in order to factor them. Okay, so in our normal trinomials, x squared plus bx plus c, we have degrees, right? Like if you think back again to grade 10, every number in every term in your trinomial has a degree, and the degree being the exponent that it is raised to. And so if we're thinking about our values of x squared has a degree of 2. Bx, again thinking about x, has a degree of 1. And c, since there's no x represented, has a degree of 0. Now we can do the same thing and factor trinomials the same way when they have degrees of 4, 2, and 0, and 6, 3, and 0. So for example, rather than this being x squared plus bx plus c, if it had the degrees 4, 2, and 0, it would be x to the 4th plus bx squared plus c. Or x to the 6th plus bx cubed plus c. Okay, because it works both ways with the degrees 4, 2, and 0 and 6, 3, and 0. Okay? So in all cases, we're going to have to substitute in order to make this trinomial possess the degrees 2, 1, and 0. So if we look at this example here, to factor x4 plus 5x plus 6, x4 plus 5x squared plus 6 can be rewritten as x squared, since x squared is x to the power of 4. And 5 times x squared is going to be x squared, 5x squared. And then nothing on the 6 because that's, again, has just a 0, no x. Okay, so what we did here is if we make a substitution of x squared equal to a, our expression will then become a squared plus 5a plus 6. And then this will then, we can look at this and factor it by inspection to be a plus 2 times a plus 3. Now the reason we do this is because it's just easier to work with the number this way, right? Like if you look at this and try to factor it, it's going to prove to be a little more difficult, just because the x to the power of 4 and x squared might throw you off. So all we're doing is we're going to replace x squared with a. All right, and in doing so, when we go back to our original term, since we factored it to be a plus 2 plus 3, we're going to reinsert or resubstitute the a for an x squared, and then that'll give us our actual factored form, x squared plus 2 times x squared plus 3. Okay, let's try a few examples. So again, we're going to let a to the 4 equal a, and remember that a itself is equal to a squared. Okay, so I guess this first statement is not exactly true here, so I'll screw that. But a is going to equal a squared. So anytime we have an a squared, we're going to replace it with a. Okay, so first thing we need to remember is that if we have a to the power fourth, that is a squared squared. Or, if I rewrite it over here, that is a squared squared, which would be the same thing as a to the fourth. And so, since a is equal to a squared, if I substitute my a squared value in there, a squared, I'm going to have a to the power of 2, since this is a squared. And then I'm going to subtract 5, and remember it's a squared, so 5a. And again, subtract 14. Now remember, if you're looking at this, we are trying to factor this by inspection. So the first thing I think about is what numbers multiply to give me 14, but add to give me 7. Okay, so what numbers multiply to give me 14, but they add to give me 7? So first thing I know is I'm going to have a and an a here, because a times a will be a squared. Now, if I look at my operations, they're all negatives, which means I'm going to have a negative and a positive. Okay, and since if I multiply 14 by 1, those are not going to add to give me negative 5, but if I multiply negative 7 and positive 2, those will multiply to give me negative 14, and they'll add to give me negative 5. Because negative 7 plus 2 will be negative 5, and then negative 7 times positive 2 will be negative 14. So those are our factors. But the last thing we need to do is we need to resubstitute our original value of a. So remember that a was equal to a squared, which means that a squared minus 7 times a squared plus 2 will be our answer. Okay, so let's move on to the next question. Again, we're going to let a, just like we did in the first one, equal x squared. Okay, and so we're going to insert every value of x squared with an a. So that'll become a squared plus 4a minus 5. And again, we're thinking about doing this with inspection, and so we need to think about which terms are going to have a sum of 4 but a product of negative 5. So if we need to have a product of negative 5, then we're going to need to work with a positive and negative. Okay, and if we need a sum of 4, then we're going to work with a positive, but we could also work with a negative in this case. And so if you look at this, again, if you're not doing it quickly yet, that's fine. But the numbers you're going to have are going to be 5 and 1. Okay? So those are my factors, and I will factor this by reinserting my original value, x squared minus 1, x squared plus 5. Okay, and actually if you look at this number, x squared minus 1, you might realize that here we have represented a difference of squares. Okay? And so if you have a difference of squares represented, then you could actually factor it one more step further. So remember your difference of squares, no exponent there, it's going to be x minus 1, x plus 1. And so again, you're looking for whether or not that is a perfect square and whether or not that number is a perfect square. Okay, and so that's our final answer. Now let's look at this last one. Remember, in the beginning we were told that we can use the same method if our degrees are 4, 2, and 0, or if they are 6, 3, and 0. Okay, so here we have 6, 3, and 0, and so if you have degrees of 6, 3, and 0, then instead of letting a equal x squared, we are going to let a equal x cubed. And the reason we do that is because if we have x cubed, and we want to make that x to the power 6, we're going to square it. And so what we're actually working with are the same terms that have the degrees 2, 1, and 0 again. Okay, and so if you're a little confused with that for now, I'm going to go ahead on this problem and I'll show you what I mean. So since a is equal to x cubed, I'm going to insert an a here, which would be a squared again, minus 9a plus 14. Okay, so see what I mean? Now it looks exactly like a trinomial that you're used to working with. If you compare this to these ones over here, it looks exactly the same. Alright, and so let's see. We're factoring still by inspection. Now, which numbers multiply to give you positive 14 but add to give you negative 9? So this one may seem a little easier just because 7 and 2 are going to multiply to give you 14, but if you add negative 7 and a negative 2, they'll add to give you negative 9. So we are going to have all negatives, and it doesn't really matter which way you write it out, you're going to get the same answer. So a minus 2 multiplied by a minus 7. And then we are going to reinsert our value of x cubed. X cubed minus 2 and x cubed minus 7. And those are our answers. Okay, so remember in the previous lesson that we looked at factoring through decomposition. So we're breaking down that middle term. And so we're going to do the same thing here. We can do the exact same thing using the exact same method if we have a polynomial expressed in what we just looked at, af of x squared plus bf of x plus c. Okay, and so when we do this, I'm just going to skip right ahead to the example, but we use the exact same method that we're using earlier on. Okay, so if we have something like that has a trinomial that has degrees 4, 2, and 0, then what we're going to do is we are going to, again, reinsert our values of a to be equal to, in this case, my y squared values. So a would be equal y squared, and we insert into the equation to give us one of those trinomials that you are used to seeing. Okay, but if we're using the method of decomposition, then remember that we look at the middle term, but we also look at the two end terms here. Okay, and so when we're thinking about the factors we need to use, then we need to use factors that, in this case, if I'm looking at the two end terms, that multiply to give me 12, negative 12, and that add together to give me this middle term of negative 11. Okay, and so if I want to get negative 12 and then negative 11, then to me the most common factors to use are going to be 12 and 1, okay, or negative 12 and positive 1. So if this is my example, then if I'm going to decompose this, then that's going to become 4a squared minus 12a plus a, or 1, minus 3. Okay, so I've just decomposed my middle term to give me that negative 12 and that positive 1. Okay, so the next thing we're going to need to do is we're going to need to factor, factor these four terms separately. Okay, so if I have 4a squared and negative 12a, then the easiest way to bring the factors out of that are going to divide it by 4a. And so I'm going to be left with 4a multiplied by a, so it's because 4a times a is 4a squared, minus 3, because 4a times 3 is going to be negative 12. And then if I already have a minus 3 over here, then I'm going to bring a 1 out of there, so that's just going to be 1 times a minus 3. And so then my factors, since I have a minus 3 and a minus 3, are going to be a minus 3 times 4a plus 1. And then from here, I can reinsert my original value of a, which was y squared. It would be y squared minus 3 times 4y squared plus 1. All right, so let's look at this next example. Remember, if you're looking at that, it's like, whoa, what is that? That is just a trinomial that has been decomposed already. Okay, and it's actually the exact same thing, exact same one we looked at, and we're just going to use another method. Okay, so the method we use here, this is the second method that's going to be mentioned up here, where you just replace your 11y into two terms of y squared. Okay, so this term we're going to replace with two terms of y squared, which has been done already. But then from here, we're going to factor it right away. We're going to think about, okay, what factors are going to go into all of them? If I have 4y to the fourth and 12y squared, then on this side, I can decompose right away. And I'm going to be able to pull out 4y squared. So rather than reinserting my value or substituting my value of a for y squared, I'm just going to leave all as is. So that's what you do with the second method. This would become y squared minus 3. Okay, so 4y squared times y squared would give you 4y to the fourth. 4y squared times 3 would give you 12y squared. And then again, we're going to factor out that 1, so that'll give us 1 y squared minus 3. And then when we factor that, we're going to be left with just y squared minus 3 and 4y squared plus 1. So the exact same answer. And so although this seems a lot quicker, sometimes it's better even to go the long route just because you can really see what's happening in each step. This one, you might have to wrap your head around which factors you're actually using. But it's also a good method once you get more comfortable with factoring. Okay, so let's look at these next examples. So factor this completely, and let's see. The first, before I do rather than doing the method we used earlier on, I am instead just going to try doing this second method. So it might take a little bit longer. Okay, so if I have 4x4 minus 5x squared minus 6, remember the first thing that we need to do is think about what factors we're going to use. Okay, so if I need to multiply to get my end terms and have to get my middle term, then I'm going to be using, I need to multiply to get negative 24, and I need to add to get negative 5. Okay, so negative 8 and positive 3 sounds like they're going to be good factors. So that would be 4x4 minus 8x squared plus 3x squared minus 6. Now if I look at these numbers, what are they divisible by? Well, these first terms, if I decompose them from here, are both divisible by 4x squared. So if I bring 4x squared outside of my brackets, I'm going to be left with x squared minus 2. And x squared minus 2, I can certainly get x squared minus 2 out of here if I take the 3's out. So it's going to be 3x squared minus 2, which means I'll be left with x squared minus 2 multiplied by 4x squared positive 3. Okay, so let's look at this one. 2a squared b squared minus 31ab plus 99. Okay, so we're going to do the exact same thing we did over here. So rather than substituting my value of a, I'm just gonna go with it. Okay, so if I have 2a squared b squared, I'm going to be starting out with that. Negative 31. So in order to get negative 31 and 2 times 99, I'm actually going to go 2 times 99, but 22 minus 9 will actually give me the factors I need, which will be negative 31. So negative 22ab minus 9ab plus 99. And actually, before I continue, I guess I'll just show you how I got these numbers: negative 22 and negative 9. Okay, so sometimes you'll need to pull out your calculator just because it'll be a faster process. But if you want to go and get the factors first, remember the same rules are going to apply even when they're big numbers like this. So when you multiply, you need to get 198, and you need to add to get negative 31. Okay, so I know it's 198 because I go 2 multiplied by 99 gives me 198. Now you need to add these numbers to get negative 31. Okay, so how are we going to add to get negative 31? Now, to add to get negative 31, you might have to play with this, different combinations of numbers. Since I don't know, if you think about all your other factors and all your other common multiples, they're not going to go into 31 evenly unless it's 31 and 1. And so let's think of numbers that we could just add to get 31. 31 plus 1, or sorry, 30 plus 1. But there's really no connection to the other numbers. So how about 29 plus 2 or 28 plus 3? Okay, so you're going to have to go and do that method. And so if I look at what goes into 198 evenly, let's think about that first example we did. 198 divided by 30 is going to be 6.6, so that's not going to work. So we might have to go down. 198 divided by 29, not even. 198 divided by 28. Nope, 198 divided by 27. 198, and actually, if you keep doing that, you're going to find it's 198 divided by 22, and that's where you get your two factors of negative 22 and negative 9. Okay? So let's continue with this. If I look at where those numbers are, they have a very close relationship with the numbers on either side of them. They're just multiplied by 11. So I'm going to factor these out. 2ab, they're both divisible by 2ab, and so that's why I choose that. 2ab multiplied by ab minus, if I take 2 out of 22, it'll be 11. And then I'll do the same thing over here, and I'll be able to be left with ab minus 11. If I get the 9 out of there, the 9ab, or just the 9, sorry, not 9ab. So 9 times ab minus 11. And so my factors will be ab minus 11 multiplied by 2ab minus 9. Alright, so let's factor this expression. Ax to the fourth plus 10x minus 3. So ax to the fourth. Now, when we factor this, remember that we need to have a product of negative 24, 8 and 3, and a sum of positive 10. Okay, so 12 and negative 2 will give us those answers. So negative 2x squared plus 12x squared minus 3. If I factor 2x squared of both of these, I'll be left with 2x squared times 4x minus 1. And if I factor the 3 out of here, I'll be left with the same thing. 3 times 4x, oh, that should be 4x squared. 4x squared minus 1. And so I have 4x squared minus 1 and 2x plus 3. 2x squared, sorry, plus 3. Now, remember, if you see a difference of squares, then that means that you can factor it a little bit more. And so here we're going to factor this to 2x minus 1. And our difference of squares tells us that we're going to have two opposite operations. So 2x minus 1 and 2x plus 1 multiplied by 2x squared plus 3. Okay, so this term will break down into this term here. Okay, so if we look at this next example, it's gonna seem kind of confusing at first. But a good way to think about this, so first of all, sine x squared is written as sine squared x, and cos x squared is written as cos squared x. We need to factor these terms, okay? But I know if you have a sign thrown in there, you'll just be like, oh man, what do I do with this? But you actually don't approach it any differently than you would approach it if there was no sign in the equation. Okay, so I'm going to keep it in here for my example, but you'll realize that it's going to follow the exact same steps that we were doing earlier. Okay, so if I have 6 sine squared x, and I'm going to decompose this negative 7, I'm still using the same method we used earlier. So I need to have a product of 6 times 2 of 12, positive 12, and a sum of negative 7. Okay, a sum of negative 7. So if we use negative 3 and negative 4, that'll give us our product of positive 12 and our sum of negative 7. Okay, so negative 3, and remember we decompose sine x, so that'll be negative 3 sine x minus 4 sine x plus 2. Okay, now we can look at decomposing it even further. Okay, breaking it down even further. Now, both of these are divisible by 3 sine x. Okay, and you'll see why. 3 sine x, if I take it outside my brackets, I'll be with 3 sine x multiplied by 2 sine x would give me 6 sine x squared. And then 3 sine x divided by 3 sine x would just give you 1. Okay, same thing over here. This is, although this term is only divisible by 2, so I'm going to take the 2 out of here, and we'll be left with 2 times 2 sine x plus 1. And so then we have our factors laid out perfectly in front of us. 2 sine x minus 1 times 3 sine x minus 2. And that is our answer. Okay, so we follow the exact same steps, and it gives us a nice, easy answer. Okay, so this next answer, or this next question, we are multiplying to find a product of negative 12 this time. Look at my two end terms, and I need to find a sum of positive 11. So I'm going to use positive 12 and negative 1. That will give me both of these. So 4 cos squared x plus, actually, here, I'm going to show you, I'm going to switch it. You're going to expect me to go plus 12 and then negative 1, but I'm going to actually do it the opposite way. So this is a negative 1 cos x here, okay? Even though you might not think that that relationship is there with those numbers, but it is. 12 cos x minus 3. Okay, so when I factor that these are both divisible by cos x, or 1 cos x, okay? So that's going to be cos x times 4 cos x minus 1. And this is going to be divisible by 3. If I take the 3 out of both these, it's going to be 3 times 4 cos x minus 1. So I'm going to be left with 4 cos x minus 1 times cos x plus 3. Okay, next question. Factor 7x minus 3 squared minus 4x minus 3 minus 3, where f of x is a binomial. Okay, so we're going to do this what we did earlier when we substitute our value of a in there. So this time though, if I look at these terms, those are kind of tricky terms to work with, right? And so rather than letting a equal x or x squared, I'm going to let a equal these whole middle terms here. Okay? So I'm going to let a equal x minus 3. That way it's going to give me a nice trinomial that I'm able to work with a lot easier. So that's going to become 7a squared minus 4a minus 3. Alright, so again, we can approach this and we can decompose it using decomposition. Okay, so if I'm looking at this, then I need to find a product of 21, negative 21, and a sum of negative 4. Okay, so my two factors that are going to give me that are going to be negative 7 and positive 3. Negative 7 plus 3 is going to be negative 4. Okay, and so I'm going to be left with 7a squared minus 7a plus 3a minus 3. And so if I look at this, they're both divisible by 7a. So if I bring the 7a out of there, I'll be left with just a minus 1. And then I'm going to add, I'm going to get the 3 out of there. I'll be left with 3. If I take the 3 out of here, that's a. Take the 3 out of here, that's going to be minus 1. And so then I'm left with my terms of a minus 1 times 7a plus 3. And remember that a was not our initial value, so we're going to have to reinsert our original value, which was actually x minus 3. So x minus 3 minus 1 times 7x minus 3 plus 3. And then we have to expand these terms. X minus 3 and negative 1 will give me x minus 4. 7x minus 21. So I'm going 7x minus 21 and then plus 3. Okay? And from here, we can break that down even further. X minus 4, 7x, negative 21. If we add these two terms together, that's going to give us negative 18. And that is our final answer. Okay, 9a plus 4 squared plus a plus 4 minus 10. So we're going to let a equal a plus 4. And I'm going to go through this one pretty quickly just so you don't end up having a longer video. So 9a squared plus a minus 10. I need to have a product of negative 90. And I need to have a sum of 1. So 9 and 10. 9a squared minus 9a minus plus 10a minus 10. 9a times a minus 1 plus 10. If I take 10 out of both of those, I'm going to be left with a minus 1. And then I'm going to be left with a minus 1 times 9a plus 10. And that's going to be a plus 4 minus 1 and 9a plus 36 plus 10. So what I did here was I just brought these original numbers back in here. Okay? And so that 9 times a, 9 times 4 would be 36. Okay, so I'm going to be left with a plus 3 and 9a plus 46.